Good afternoon, all. My name's Tabitha Binding. I'm Head of Education for Timber Development UK. We'd like to welcome you to TDUK's webinar series on engineering with timber. This series aims to add to your engineering education so that as we transition to a bio-based economy, you have the tools and knowledge to include timber within the projects you work on, whether new build or retrofit. Webinar 8 is a bonus session in our Engineering Timber series and is an introduction to engineering for fire safety. Timber Development UK has been formed from the merger of two of the largest and longest established organisations in the supply chain, the Timber Trade Federation and the Timber Research and Development Association. We are seeking to connect the supply chain, to lead best practice, and to accelerate towards a low carbon future. Our platform is Zoom meetings so that you can communicate with us and your peers. Please post any questions in the chat and we'll come to them at the end of the presentation. We'd ask you to keep yourselves muted, but happy that if you would like to put your camera on, you're welcome to. So in this final webinar of our engineering series, we take a look at the essential principles of engineering timber structures for fire safety and how these are being applied by practicing engineers in their building designs. Our speakers are Alan Dowdall, a leading engineer and director at Ramboll, and Dr. Julie Bragula, the creator of a new resource, timberfiresafety.org. Together, they will show how to make the best use of this resource. I'd like to hand over to you, Alan and Julie.
Thank you very much, Tabitha, and welcome to you all. We're very delighted to have you here, and I recognize some of the names, so great to see you here, but I also many new names, so it's great to have you here with us today. I will share some slides, and Alan and I will be sharing this a little bit, so it's not one of us and then the other one, but we sort of see it's a little bit intermingled, so hopefully that be interesting. It's an introduction to the resource, so it won't be going into detail on all things in the resource, but hopefully make you feel really confident about using it going forward for more details to come soon. So here we are. I hope if Tabitha and team could confirm that you can see that. Sorry, that is... Does this work?
Not full screen yet. Yeah, perfect.
Excellent. Okay, so just a very quick introduction to this new resource, which has been developed together with Timber Development UK, the Structural Timber Association, and Swedish Wood. The aim and hope for this site for all the three founding partners really is to sort of provide a robust, comprehensive, easy to use, but also an independently verified portal for fire safety and for timber specifically. It's applicable primarily to the UK, but aligns with European practice. So when you see some regulations quoted, they are UK regulations, but it links back into European regulations and standards as appropriate for the use in the UK. It is really, really difficult. Fire safety is a hugely complex subject. And so I will not endeavor to be as eloquent as these two Italian illustrators that are really able to sort of communicate some of these really complex and long movies in just 5 seconds. I guess you all have guessed by now what movie that is. So I won't be able to be that quick with it. And I think the main reason for that is because the interfaces around fire safety are just so complex. We're talking about safe assets. We're talking about the products that we use, the processes by which we sort of employ these products, but also the people that deliver them. So as such, it's a really complex field, and sort of really the website is here to try and help with the navigating some of this complexity. It's really important. This is just the latest statistics for the UK on total fires attended in year, and you see just the amount of number of fires that we see every year. And so fire is a real design case. It's something that's assumed to happen once in the lifetime of the structure. But this is also an interesting statistic, which I normally bring up here, which is about the statistics of damage that we get when a fire does occur in a building. And so really the average area of fire damage, and all of this you can glean from the statistics that the UK publishes every year, is about 14.2%. And that's in dwellings, and we've got in other buildings about 24.1%. In 1/3 of all dwelling fires, there's no fire damage at all. In nearly 1/3 of all fires, we limit the fire to the first item ignited, or actually we limit the damage to the room of origin. And then really 4% of all fires really are large fires. And what we mean by that is they sort of are on the floor of origin or affect more than 2 floors in addition. So this is really, and to achieve that is really to enable the fire to be controlled at source quite quickly and efficiently. And that sort of meets the fire safety objectives, which are actually overarchingly the same wherever you go in the world. And that sort of has these 5 main aims always: that the occupant shall be able to leave the building or be rescued, that the safety of the rescue teams is taken into account as much as possible, that the load-bearing structures resist the fire for the required minimum duration, that we generate, that we limit the generation and the generation of smoke and the spread of fire, and that we actually limit the fire as much as possible to the originating building, so that the spread of fire to neighboring buildings is limited. And so these underpinning principles is where really all fire safety expectations come from, and the way that we manage those and how we actually implement them in a completed structure. And so this is, we're not going to go through this in much detail, but it's just really to give you an overview. There is always national regulations that talks about how we prevent fire ignition. And then there is one set of measures that look after managing the impact of a fire when it happens. Yeah, and we do that again into 2 subsets. We do something about suppressing the fire, controlling the combustion process, and containing the fire within the construction. And we do something about what we do about the exposed bit of structures and what we do about that. The fire safety site sort of deals with all of those various aspects of these fire safety objectives and how we deliver them. And so you've got a little bit at the top bit there, like foundational principles, you know, so where do we see timber and construction in the first place, but what do we aim for when we design for fire safety in buildings? What regulations do apply in Europe, specifically in the UK, and their interactions, and also the design approaches that are available to designers depending on the type of structure and the application of the products that you're looking to use. And then those 2 pillars that you see underneath, the way that you design for fire safety around load-bearing walls and constructions, about connections, separating walls, surfaces, internal and external, and how we manage construction for fire safety at the start, during construction, but also through life, as we maintain and look after structure and occupy them. This is really just to give you a very quick intro as to all of the content covered, and Alan will sort of show some of those principles in application. So over to you, Alan. I'll stop sharing now.
Okay.
And then it's over to you.
I shall share my screen.
I'll just stay not on mute until I can see it, so you know it's happened. And not quite yet. It's there.
Okay, so I'm going to have full screen. All right, thanks, Julie. My background is in structural engineer. I'm a structural engineer, that's what I do. So I'm going to focus these slides onto from a structural engineering aspect for timber and fire. I've got about 30 slides, so I'll try and whiz through these pretty quickly. And this is sort of the flow, which I want to sort of go through things. So I've got some project examples, which are just images really of projects, and there'll be a theme probably through that, which I'll explain at the end. And then I'll touch down into nitty-gritty about actually design scenarios when it comes to fire, which is an accidental design scenario case as opposed to a typical case. And there are differences in approach that are taken in the design of a structure between these 2 types of scenarios. And following on from that, we'll just have a chat about how timber behaves in a fire, how it reacts to elevated temperatures, and a very quick run through in terms of examples of detailing, particularly around connections, how we look to protect connections, so forth in timber. Okay, so some project examples, and these are not quite in chronological order, but close enough, and you'll see that they tend to get quite bigger as we go through the ages. So we're going back to one of the oldest ones. This is a form-based swimming pool. And this type of building is single stories on the ground, and the structure is really just supporting a roof. So in terms of fire risk, is actually quite a low profile one, and we don't tend to put a fire time on the roof in terms of design from the structure point of view. But it's quite a nice sort of frame that you get with the timber. Other types of timber buildings that we've worked on before, this is a Beechwood West, which is low-rise residential, and these are actually timber modules. So if I just skip on one, you can see this is one of the modules that goes into one of these houses, and that has a different fire risk profile. Mainly, there's a lot of party walls that need to be dealt with in that case, which we had to detail to allow for an increased protection in those lines. And we move into different types of scales of building, from say from cultural residential to educational. We're getting into a different type of building, which comes with different design aspects to be considered within you got a much bigger space to deal with. So this is a school in Norwich, where we have a lot of exposed timber, but it's not a high rise per se. Moving forward in time, and we've got what we see today is more commercial buildings. This is a office building in London. It's about 5-6 stories. Again, using its extension to an existing building, to be fair, and that's done from mass timber, so glulam and CLT, and that again comes with. These are all different types of buildings, and they all have different sort of rules that you need to follow when you're looking at designing them from a fire aspect. And then just sort of looking forward where Tim is going. This is a snapshot of some of the pipeline projects that are in the works around the UK and Europe, where they're quite large scale. So there is a trend of buildings that are increasing in scale using timber for various reasons, very good reasons, to mostly around the carbon and lightweight nature of timber, and they all come with aspects of fire that needs to be considered within the design. And obviously, as the bigger the building gets, then the bigger the risk profile is for that scenario to be considered. So just going to take a little step back from that and move on to the next stage. So focusing in on structural engineering, and talking about how do we consider our design scenarios from a typical loading aspect of a building to a accidental scenario, which is a fire, for example. So we've got the typical, and then we have our nice little graphic there that shows perhaps a fire scenario. So we compare how that works with some of the loadings and factors in our, let's call this, for example, an office loading. We have a certain amount of loading which is more of in the upper percentile. So for an office, we'd have 3.5 kilonewtons per meter squared. That is approximately 5 people per meter squared, which is quite a tight range. So it is certainly an upper limit of what a floor would most likely experience. And some offices from studies years ago show they're more like 0.5 or even less in reality. When it comes to an accidental design scenario, there's more of a pragmatic approach to it, in that the likelihood is you're going to have a lot less. So if we apply the office theme again, our loads are about half certainly the imposed load, so the people and the furniture is taken as about half. The actual finishes on the floor are still the same; they don't change. Then we think about our factors. So factors of safety and for design of strength in a typical design scenario where upping those loads by, so for live loads will be by extra 50% or 35% if it's just the finishes of the dead loads. And when it comes to accidental scenarios, we're keeping our factors at 1, so it's more of a realistic approach to it. So that's how we deal with loading and our safety factors. When we then look at the material properties, hopefully you're aware, when it comes to design of structural materials, we have a distribution of properties that any of the materials, whether it's steel or concrete, will have. And in design of our structures, we're taking the 5 percentile as the characteristic properties. So if we were doing the load, say, we're taking the upper load for the typical design case. With timber, it's such a variable material, and the Eurocode actually takes a different approach where it goes, well, rather than the 5 percentile, that can be increased to a 20 percentile. So you can, for a glue lump, say you can get like an extra 15% capacity out of its strength and properties, which is, so you combine those two things together, you have a slightly reduced loading to an accident scenario and slightly better properties in the pardon me, in the accidental scenario. And you combine that then with when we look a bit at Chara later on, how if you have a reduced section, you combine all these together to work out the utilization of your structure and design accordingly. So just some notes, I guess, on reaction to timber to fire. Most structural Eurocodes are taking into account a standard fire curve when it comes to design, and this is a very simple equation-based curve where you get a rapid increase in temperature initially, and then it sort of flattens out, and it just keeps going and going and going. So to give an example, at about 3 minutes, you'd be at 500 degrees, which is near the halfway mark. At about an hour, you could be at about 1200 degrees. Sorry, just to explain this, the temperature side is on the y-axis and time is on the x-axis. In reality, how a fire dynamic would behave in a compartment looks a bit different than that. We have various stages of a fire. They tend to start off, we have some sort of ignition period, a growth phase along here, and then at some point there'll be a flashover where there's a rapid acceleration in the temperature of the space and the severity of the fire. That stays developed for a period of time, and then it will dwindle down once the fuel in that compartment has been consumed, typically. And they're the stages as you see them there. When it comes to timber, if we're exposing timber within a compartment, there is more fuel in that space than there was, say, if it was non-combustible, if your structure is made of non-combustible material. Pardon me. And so there's a possibility that depending on the fire dynamics and the space and how enclosed it is or what the arrangement is, things can be quite different. So there's a possibility you can have a more severe fire that goes on for longer, slightly hotter, so forth. And certainly with some of the types of glues that could be used, is if the fire goes on for long enough and if the heat line reaches a certain glue, if it's not heat resistant glue, you can get some failures that can happen with a delamination in a second flashover. So it's important to, I think, when you're looking at certain types of buildings, that you have a fire engineer who can understand the dynamics of things. And just to put this into context, this is sort of a graphic from a fire test we did some time ago, where you have a sort of those phases in place. That went on for a bit longer, had a bit of a second flashover, and then it died down again. So putting that into context from in terms of structure, these temperatures are ranging from the high hundreds to 1200 degrees. What does timber actually do when it has an elevated temperature? So if we look at the strength of timber with temperature, remember we said they're high degrees of temperature. It's an extract from the website that Julie was also an extract from Eurocode, where we can see here, again, we've got the strength factor on the Y and the temperature on the X for whatever the structure is doing, your timber structure, let's say compression, tension, and shear. There is a reduction in its capacity, which is quite sharp, especially for compression. That is, which should be taken into account. So how do you deal with that? These are known numbers. How do you deal with if you have a severe loss in temperature, strength? How does that factor into your design? Well, there's two ways really. One is, we don't actually want maybe the timber to engage with the fire, so we have some level of protection. That can be beneficial in terms of what we're saying about the fuel to a compartment, and what's a common terminology is encapsulation, which is covering of the timber with boarding, non-combustible boarding, to prevent that timber being exposed to a fire. Again, looking at this graphic from the Eurocode and the website, if that boarding is shown to have a certain level of protection, should it fail, there's a elevated charring rate that happens if it happens to be exposed. So really kind of want to design it so it doesn't get to that failure point. So just to explain this graph, this is a sort of, if there's no protection, that's the sort of linear rate of charring that would happen to timber. If there is some protection, it will not char for a period of time, and then once the boarding has failed and fallen away, there could be an elevated charring rate, which I'll come on to in a bit, because you've exposed this sort of fresh timber fuel to a sort of elevated temperature. Okay, other means, perhaps active protection, so sprinklers. These days, sprinklers for timber buildings are almost a requirement based on insurance and asset protection. But from a life safety point of view, we're always assuming that in a fire scenario that there is what happens if the sprinkler system wasn't working. So from a structural design point of view, we're looking at the natural charring of the timber. So while you've seen that graphic from earlier that showed how timber has low strength capabilities in elevated temperatures, the advantage of timber is it's not a conductor like steel. So it forms a char layer. Sorry guys, I'm getting over a cold. It forms a char layer that has insulating properties, and behind that char layer is a couple of things. There's a paralysis zone, which is what we're saying has a zero strength area, so it's not taken as part of the structure. And then behind that bit is a uncharred timber that has retained its strength properties. And again, taking some graphics from the website, you can see that the distance from the char line and the temperature of the timber material behind that char line it falls away quite sharply from that point. So when it comes to looking at that zero strength zone, it's averaged out over about 7 mil. although I believe that will be updated with the new Eurocode comes out at some point. So charring then is done at quite a predictable rate for a fire. If we're using the sort of standard fire curve, the fire never dies away. We have a set number of minutes. We can predict and work backwards to design our structural elements for the sizes that they need to be. In many cases, depending on the building, then if we have 30 minutes or so, we can. Fire scenarios are really the critical factor for our members. It tends to have built in some of that inherent protection. There is a difference between panels and members. So if we have a panel, there's a certain char rate, which is a flat rate. When it comes to, say, corners and beams, there's a sort of rounding off that happens. So you have two surfaces that have been charring, and they have a sort of rounded surface, and that is compensated. And we have different char rates to deal with the sort of loss of a rounded edge. So you have sort of overcompensation to remove a few more additional millimeters of timber. And then on top of that, you have your zero stiffness there. So the analysis model is more square, when in reality it's cornered, which you can kind of see from this sort of test section from a while ago, where we've got rounded edges on the bottom, and it's sort of the whole thing is quite rounded. Whereas on a flat surface, it's consistent. So just thinking about glues as well. Glues in products will have an impact on the performance in a fire of the timber, and there are several types of glues available in the market, but if we were to categorize them, well, some being heat resistant and some being non-heat resistant, and I want to put this in context with what the graphic I showed earlier in terms of protection. If protection was to fail, then you have that sort of elevated charring rate. In this case, if the charring line, well, it hits a glue line, or you get the heat temperature hits a point where you get bond failure, there will be a elevated charring rate, so which is double for a certain amount. In this case, it's 25 mil. Before it then settles back down to normal and into its typical slower rate of char, because it's insulated from that bit. So if we have, say, take this as CLT section, if we have one product which has a heat resistant type of glue, so say MUF, then that will give you a level that is consistent over time, and the charring depth is as expected. If we do get some delamination, then we need to account for that, and that's where we get the higher rates when delamination happens for a certain amount of the section. Okay, then moving on about detailing connections. Really, if we look at what a typical connection entails, it's generally connecting two members together. The image here is basically, it's a column to beam connection. It's very familiar to most structural engineers, and when it comes to timber, we are using metal connectors 90% of the time, if not 100 at the moment. What this does is we've got typically a flitch plate or a steel T section that's fixed to, say, a column, and then the timber member, glulam member beam comes in, and it's doweled through the beam, through the metal connector, and it bites into timber from there. If you're exposing timber, there's usually a dowel to hide the fixing. But this is just an example. Sometimes it's bolts and whatnot. when it comes to, well, so I just go through an image. So this is sort of an example of what that image looks like. You've got your column, and there'll be a beam coming in to the side, and looking up above. This project is just behind the back, King's Cross. So if anyone's around there, you can go and see it. And what you can see is we've got these plugs, and all these plugs are actually quite deep. They're what we want to avoid. I said earlier, metal is a conductor. We want to avoid the temperature getting to the connector and softening that metal, and eating into the capacity of the connection to work. So we're putting sort of strips around the side for sort of the temperature can't get into the connector. And we're also where we put in the dowel connectors, we are plugging them with timber, using the char rate on timber to size those plugs so that the metal will not experience the heat from the fire. And you can see something that's quite deep, and that's to allow for that to happen. It's also what noting most of all buildings really are actually hybrid structures. So there's always going to be probably some level of steel this is the core of that building, and that's surrounding that is your timber frame. And if you're going to connect to that, there'll be some sort of metal fixing typically. So you still need standard intumescent painting to fix that, to protect that metal from elevated heat. So it's not much different than before. Just final slide, really, I just want to talk about this is hybrid frames. There's a tendency in some schemes to look to reduce the height. If you're doing a combination of steel and CLT, you're raising the steel beam up into the CLT. The point I suppose I want to get across, it's quite easy from structural engineers to think about the structural integrity requirement, but we should also be aware that there is an REI requirement. So OR is a structure from the regulations, on the approved documents, I should say. The insulation and integrity are also a requirement, and what we need to be considering as a design team on board is if we have a steel beam like this, is that going to conduct a temperature gradient up to the next space, and does that need extra coverings to stop that temperature, which is about just under 200 degrees between a compartment, to meet that sort of compartment requirement. So there's things that don't just think about the OR value, but in the whole, you still need to do that. And that's in combination, not just with the structures, but design team and fire engineers and so forth. Okay, and there are my slides. I think we're probably on time. I'll probably hand back to you, Julie, to talk a bit more about the website.
Yeah. Thank you so much. Yes, I'm going to just share back. So this is the final bit that we wanted to show you. And I wanted to really link a little bit some of the concepts that Alan has talked about and show you a little bit more about how the website helps you with that and with your own project. And so one of the bits we've been really thinking about is to who needs what, right? So you all come with very different experiences. Some of you have, already worked with timber, some of you might have not. A small and large projects. I mean, Alan has showed us some of the larger projects, but of course, some of you might be timber frame dwelling projects, so there's a real range. And actually, it's industry-wide, and there are many and various stakeholders. And so to help with that, we've sort of really organized all of the topics surrounding fire safety and timber specifically into sort of 3 layers. An introduction of the principle that is generally material agnostic. So, this is sort of the principle that applies and links to those objectives that I've showed you at the start. And then in the second layer, some specific examples which relate to timber. So how would one meet the principle if you were to choose a timber solution? And then a third layer, which is really then getting into quite a bit of detail, maybe some further reading, cross-referencing to other places where you might have more detailed information, maybe where some research is ongoing. And we completely appreciate that depending on where your knowledge level is at any one time, you might then access different parts of this sort of information. And you might be really good at one topic and you know everything about it, but you actually would like to understand a little bit more about something else. So really what this is trying to do is not to replicate or do any, add information, but it's to organize the information in a way that would allow you to access and understand it in context to the principle you're trying to meet. And the next thing we've been thinking about a lot is, when do you need this sort of stuff, right? So who needs what, but also when do you need it? And so really, when we designed the site, we've really been thinking about these sort of REBA stages. And so we think it's really a good resource for you during the consultation stage, at concept design, when you sort of think about your fire safety strategy. When you do high risk and complex projects, your qualitative design review, for example, when you start sort of thinking about performance objectives, that's a good time to use the site and you find information relevant to that. In REBA stage 3, when you sort of think about internal layouts, you agree assessment methods, you talk about input parameters with your clients in your supply chains, when you start speaking to authorities, this is a good time for the website as well. And of course, in the technical design, of which Alan has showed you some very specific details from his experience and his projects, which are amazing, and sort of really innovative around timber as well. So this is sort of what we've been thinking the website should be catering for and giving you information. And this bit about, I wanted to share with you really, because of course, timber and increasingly so is used in a range of applications, and we've also given you a little bit of information around when you might find which particular types of these strategies that we talked about, from prescriptive to performance-based design, to when there might be a mix depending on the type of structure you have by height, but also the complexities, the protection requirements that you might see, and the firefighting strategies that you might employ for structures like this. And so I think that the examples we've seen with Alan were more on the sort of the tall with some complexities, or very tall with complexities type bits. But of course, we'll also seen one example of residential construction, where you might employ slightly different techniques. And this is really my last final slides, but I wanted to maybe just show you what the site looks like when you go and you click on the link. Which of course Tabitha kindly sort of left you in the chat. So this is a typical example, and sort of Alan covered a little bit reaction to fire, so how timber surfaces react when they're exposed to an accidental fire event. And this is how it would be. So this is a typical introductory bit. What are we trying to do? It introduces some of the background, where you might find some of the relevant regulations and standards for this. So you give quick access. All of this stuff is cross-linked, so you can read and quickly get yourself into different place with a sort of a cross-reference, which is kept up to date. And then also for UK users, you get some really specific UK implementation best practice also on the site to sort of guide you on that. If you then were really in the mood and you sort of think, yeah, I get all of that, I know all of that, I want to just see what happens actually with timber specifically, this is a typical layer 1 type information, where actually you unclick a bit of more detailed information about what the product might be like, what might be the end use condition, and sort of what might be the typical ratings, for example, that the reaction to fire classification might be. So that's sort of a good example of that. And then I think what was really key for us, and sort of further useful information, is to really allow you to cross-reference and cross-link to best practice from across the UK in entities that sort of do this really excellent work around enabling timber and safe use of timber in construction across many. But this, for example, is sort of contextual links to UK best practice from the Wood Protection Association, for example. So where might you find some additional information on fire retardant treatments and bits and pieces like that. And then really, where possible, given some really practical considerations to think about, right? So, you might think about high retention levels. What does that mean? I'm speaking to my supply chain. I'm not quite sure what that means. And you sort of get a little bit of background to inform your discussions here. And then really some typical example where you can go to best practice across Europe with UK limitations, right? So you might have, you pick up Eurocode and you see a couple of tables in there, but it will also explain which tables will be applicable in the UK context and which are not, and what you might do instead if those tables. So what is guidance and what is sort of further information for you to sort of develop your design solutions or inform your communications with your supply chain. So that's really it. I think you've seen a little bit of everything here today, some excellent examples and brilliant examples of sort of timber construction in Alan's remit, but also some of the information that you might find. There is lots and lots more to explore, lots of more information there. The final thing I would want to say to you guys, it's an updated site. The three founders, so Timber Development UK, Structural Timber Association and Swedish Wood have committed ongoing funding for this site. So please return to it often. There'll be additional information, there'll be additional content, and there'll be updates as our sort of regulatory picture changes. So will the site. So this is really important go-to resource that hopefully will accompany your projects from here on in. So this is it. Thank you very much. And I think we're over to questions, Tabitha. I'll stop sharing.
Yeah, thank you, Julie and Alan. Absolutely brilliant. There's such a wealth of information. Just on your last point, Julie, absolutely fantastic that obviously it's going to be updated. How do people, if they come across something, or who do they get in touch with? How would they put something forward?
Great question. Yes. So it is. So you will find on the actual website there will be there will be a leave a comment bit, so you can get in touch. So it's not a live, so there's nobody sitting on the other side of that, so it's not a Q&A type interaction with the site, but we are absolutely, this is a very complex subject. It changes quite a bit if you spot anything, and if anything isn't clear, if you sort of think, oh wow, I thought that moved on, this is the place to tell us, and we're hugely appreciative of that. So it is curated and looked after all the time. So please, anything you find, anything you'd like to see is also great to put there, so we can put that into our work program.
Brilliant. Right, we've got a flood of questions coming in. Some of them might be, you might be able to answer, and some not. I'm just going to go through it as they are. So Alan, probably one for you from Niall. How do you deal with charring at a timber bearing connection? Is there increased charring at the interface? Example, a beam bearing on a column.
Alan, do you want to take?
Yeah, fair enough. I'll take that. I mean, timber likes to bear. Is the my answer to that, in terms of any connection detail. If I can get away with it, I'll try and bear timber onto another member, as opposed to using that connection detail I showed you before, and that makes it a lot easier, because it performs a little bit of a seal on top of itself, and it will protect the insides of it. It will char, but we have got that extra charring rate that I talked about for members where there are sort of corners involved. But again, bearing on timber and bearing is the best way to go in my experience. There will be some metal connections in there just for tying purposes. So it'll be again probably a dowel of some sort, and again, what I was saying, where those dowels are plugged with timber to avoid the heat getting to the metal fixing. Hope that answers my question.
Yeah, thanks, Alan. Probably to both of you, how are insurance companies reacting, obviously, to fire and timber and the insurability of buildings?
If I lead on this just with the site, so the site has been developed with insurance feedback and input as we were developing what we're covering and how we're doing it, and we've really had great reactions to that, just saying this is really helpful. It allows us to understand and also inform our discussions and the way we go, and actually requests for being kept involved and up to date on that. So that's been really encouraging. It fits into a wider set of information that also comes with other industry initiatives that are about to be launched and coming along. So you'll see this really as part and parcel of some of the commitments the timber industry is making to the construction built environment more widely.
Yeah, if I can jump in on that as well. My experience with insurance providers is that they have shifted position in the last couple of years, from not really wanting to do anything quite different that they're used to sort of understanding that this is probably going to happen anyway. There's going to be more these timber buildings, so there's an element of, well, we need to engage with it to be able to control it in some ways. But also, I think in design teams, historically, we've never had to deal with insurers before. So it's quite nice, really, to talk to another stakeholder about what their concerns are. And sometimes, well, actually, a lot of times, there's some low-hanging fruit that will help to ease their concerns. And their concerns are risk-based concerns. So what you're doing is helping de-risk the building anyway. So it's about having those conversations. You want to deliver this type of building, having an idea where you're going to go with it. You won't have solved everything at the early stages, which sometimes they might ask you for, but you work with them to develop it through the design REBA stages that Julie put on the screen not so long ago.
Oh, thanks both. So from Moshen is looking at fire safety implications using different types of mass or engineered timber. So are there any particular concerns when you're almost like hybridizing mass timber buildings? When you're joining cross-laminated timber and glue laminated timber?
I mean, there are many different timber products out there. Some of them, like stick builds things don't have, because they're quite small sections, don't really have a lot of fire protection inherent within them, and they will probably be covered up quite a bit. I think rather than doing cross laminated and glue lam, if you just think about what is the product, how is it put together, does it have an element of massness to it that will an element of timber that will, if it was charring, will it char a bit and still have redundancy within the system? But it's quite a hard question to answer, because it's almost how long is a piece of string at times. So I think you just gotta take each product on its own merits and understand the makeup of it, and be able to design to the benefits and constraints that it provides.
And I think, again, with all of these sort of really complex questions, what I always find is it's sort of a layered approach to understanding what might be the expectations and requirements on the structure, what might be its use, and that sort of layers in a little bit. So again, I feel like if there is a way of like just finding your way through some of those various requirements as they come along, and find cross-linking, and sort of, it's a little bit like, I'm hoping the West will be like, getting lost in YouTubing or something, when you're trying to find something and you do, oh no, that's quite interesting, I'm going to click on that. But it's just to sort of start laying out what's the information out there, what should inform my thinking and my discussions as I consider some of these things. So yeah, I do hope you get I don't wish to waste your life away, but if you could on this site, I think it'd be time well spent.
I love both your passion. It just comes through. It's like, well, go and do some more research and get lost in it. I think you answered this partly in when you were both talking, but Pasindu has asked, is there anything we need to be aware of in connecting timber members to steel beams?
Yeah, I think that maybe my final slide might have covered that a little bit. From structures, you can probably make a lot of things work. I think where you have to just have an understanding outside your remit a little bit, in terms of, it's not just always about structure. Fire is about a system of things in place. And the example I give, if you have a compartment where has routes of access for temperatures to go through, then that's not necessarily, you might have got the structural integrity right, but there's other factors like the insulation and the integrity of the compartment to perform for the space that it needs to perform to. So my advice is, go to the website, check it
Very
out.
good,
Yeah.
Alan. Because there's a very specific section on detailing, actually cross-referencing best practice from across Europe. Excellent work being done across Europe on really great research into fire paths. What do we see in timber structures specifically? What are weaknesses? What are strengths? I think we've got actually a colleague from Europe on the call here today, which is great. But again, great work being done across Europe on that. And again, the website references to that and really gives you some of those higher level details, so you can quickly get an idea and assimilation of that, but gives you full access to the text behind it as well, so you can further research what might be applicable to your situation.
Oh, thanks both. That also sort of leads in probably to the next question was, are you aware, or what are the most promising innovations in mass timber fire safety research? Or is there anything you're aware of?
Yeah, I mean, I would just say, if I said, I mean, it's amazing to see of how much effort and research is happening, you know, on this, which is a great asset, and also just speaks of the industry that is trying to really make timber happen safely, and that's brilliant. So the site represents what we know and what we agree that we all know, and really links back to ongoing research as much as it can, including links to where you can find updates on milestones, where people have completed particular parts and are maybe publishing something in between. So again, a real call out to everybody that is sort of finding something and think, wouldn't it be great if that were linked somehow? Just let us know about all of this stuff, because it's a really fast moving field, rightly so, and it's important to keep abreast, but also to have a place like this to anchor it all so you can access it quickly.
If I could just sort of mirror what you said, it is amazing the amount of investment that is happening over the last 4 years or so in terms of testing and whatnot. And I think that from what I see, it's done in 2 ways. It's done from industrial bodies, but also a lot of private developers doing some testing, which I've helped some out with. If there is any developers who've done some testing on the call, my call would be make it open source. Try and share that knowledge with the industry, because I think it benefits everyone in the end.
Wholeheartedly support that, Alan. Yeah, if we are to build with timber and build better and like for long use, then yeah, sharing our knowledge is so beneficial. Probably one for you, Julie. Within the website, so Ian is asking, to provide limitation of smoke and fire spread, what considerations are given to the positioning of fire and smoke dampers when designing a building in timber? Is there maybe?
Excellent question, and yeah, I completely agree. Such an important thing to get right. I mean, there's one thing about getting the properties right and the design right, and then there is about really managing fire safety through life. So there is a dedicated section on that on the website. There is links to approved products and how you go about that. How does that work? How are these things tested? So all of that information is on the website in the managing fire safety bit. So the right side of my sort of flow chart that I've shown you. But yeah, excellent question. And I think one of the really big important topics for delivering fire safe buildings in timber.
Thanks for that, Julie. One final question on the around timber, and then somebody's asked about, Alan, about the first slide you put up, and can't resist going back to that because that's got moisture involved. So final question, from any new implications from the Tall Building Safety Act that came into force this October?
So I would just say we have tried to reflect what as best as possible the cross-linking, right? So people always go to the latest version of everything, so that's in the site. We have so where any subject, any topic is either not clear or not actually yet decided upon, so we're talking about combustibility, we're talking about, what happens, and I saw a couple of questions around how about this and how about that. What we're trying to represent at the site is basically the level of knowledge that is agreed upon, and then any sort of outstanding questions or whatever is sort of highlighted, right? So that you always go to the latest version of something. What it is not, it's not a go-to resource that says, and this is how you shall do do it. It's really trying to cross-reference where others might have published on this particular subject and linking it to the principle, be it coming out of the Act, coming out of the building regulations as we know them, or any other sort of requirement. So that's sort of what the site is trying to do. So not necessarily answering the question directly, but just so you understand how we've constructed it to help answer and sort of guide on some of these issues.
To be fair, I'm not sure you can fully answer that question just yet.
Yeah.
A lot of secondary information has only just been released as of, I think, mid-August. So there's sort of people diving into that to understand the implications of it. So it's probably more of a case of once we get through that, it'll be.
And Alan, I think just to reinforce, it's very normally somebody builds the sites and then it's there. Really, all three funding organizations, which I shall name check again because it's amazing. So TDUK, STA, and Swedish Wood have committed funding through the life of the site to be able to ensure that the content can be updated as some of this sort of knowledge comes into solid referencing status.
No, that's brilliant. So basically, watch this space, keep an eye on the website, anything coming up or anything.
Keep going back. Yes.
And feed anything back to us, and it will be updated. So this is just for Alan because it was a fantastic first slide you put up. How is it, with the timber and the swimming pool? Obviously, you've got water, which is also challenging when you're dealing with timber. It was just, how was the moisture control addressed? Because you had those beautiful beams that were.
Oh, it's even worse than that because it's water with chloride in it, so it's really corrosive to metal. But what I will say, timber, swimming pools, swimming pools are actually quite highly ventilated buildings. So it's because it's known moisture, and the levels of air changes are quite high. So the servicing is dealt with, and I think when water's in the area, you plan around it and you detail it. Like I say, it's quite dry. Actually, we've had to make sure that the timber shrinkage isn't too excessive from our members because it'll dry out quite quickly and shrink quite a bit. When it comes to timber and moisture, it's the known unknowns that you can plan for. It's where the real risks are more to do with the bits that you can't see. So the likes of roofs and things, have you got processes or design items in place that allow that to drain freely, or how are you dealing with internal spaces such as showers and things like that, where if there's a leak around the shower, how does that get detected or managed? They're the high risk areas. Swimming pools, not high risk actually, and I think timber is probably the best thing for a swimming pool because it doesn't corrode with the like steel would do. That was a hybrid structure that you've seen in that former swimming pool. The steel cabling on that, or the tendons on it, had a high level of galvanization occurred to it because we're worried that the environment is corrosive to metal, but timber hasn't got that issue. So I think timber and swimming pools are quite a good. Actually, I see a lot of them. There's a lot of them around the country. They're quite nice environments.
Thank you for that, Alan. And Dr. Julie Brugula, I will try and move the slides on now, as I just got stuck. So on the TDUK website, we hold a lot of timber engineering resources. So please look at those and download them. We run a student challenge to encourage our future engineers to learn about timber and to work across disciplines, not only within their own. All the webinars in our series have been recorded and are uploaded to our website. It's a quick list of them. So what we've covered so far, we know we will be coming back next year with a second series. So if you've got any engineering, sort of further engineering, or want to talk about more engineering in depth, please again pop us a message and we'll see what we can do with those. So with that, I'd just like to say thank you very much for attending and enjoy the rest of your afternoon.